Hi there, Algebra 1. Today we're going through lesson 4.1, using graphs to relate to quantities. Okay? Now, my objectives to represent mathematical relationships using graphs, analyzing a graph. The graph shows the volume of air as you blow it up until it pops. What are the variables? Well, the variables just happen to be this time are going to be your two labels on the side of your graph. So one's going to be volume, because that's going to change. Volume, and the other one's going to be time. So those are my two variables. Okay? Now describe the variables are related at various points. Well, first thing is when volume increases, we are blowing air in the balloon. Okay? Okay. What is going on? Okay. The other thing that's going to take place here is describe how the variables are related at various points on the graph. Well, the other thing is when volume is not changing, you are taking a breath. Okay, how does it keep ending up down there? Really? Okay, you are taking a breath, and so on. So that's how I describe that one. Okay, what are the variables in each graph? Well, first one here, we have board lengths. So say we got this 16-foot board, okay, and it is not changing. Over time, it will change. So we have length and time. My goodness. Okay, those are my variables in this first one. Okay, what's taking place is after amount of time we cut the board. Then it'll sit there for a while and then we'll cut the board again. Okay, the other one we have is cost and minutes of calls. Those are my variables for the next one. have going on here is you have a flat rate for so many minutes, and then you get charged per minute. Okay, so there's that one. Okay, matching a table and a graph. A band allowed fans to download its new video from its website. The table shows the total number of downloads after 1, 2, and 3 days and 4. Which graph would represent it? Well, first off, doesn't it look like your views are going up every day, which probably should happen unless no one likes your deal, and then it'd kind of back off. So I'd get rid of D, because that's saying it was going in a negative direction. Okay, now you have you are down to A, B, and C. Well, A is going to be going up by a constant rate. So are we like adding the same amount every day? I would say more of a multiplication of A, like of 3. So I would throw A out. So you're down to B and C. C shows that it's kind of leveling out. Do you think it's leveling out based off of the numbers you're seeing? I would say no. So B would probably be your answer. Okay. Okay, once again, matching a table and a graph. The table shows the amount of sunscreen left in a can based on the number of times the sunscreen has been used. Use a graph that could represent the data. Okay, so every time you're using what, about 0.2, and it's getting less and less, and that makes sense. So I would probably, none of them could be thrown out by that theory, because everything is decreasing. Do we ever get to where the can's empty right now? No. Wouldn't say we're at that point yet. It's not going to be quite that rapid anyway. The B there, it's kind of like, oh, we used a bunch because we had a bunch. We're going to use a little less because of that. And then there's C, which has kind of a constant rate. I would say probably C there because of the fact that you have a constant rate going. A model rocket rises quickly, then slows as the fuel burns out. It begins to fall quickly until the parachute, after which it falls slowly back to Earth. Wow, what sketch of a graph would represent the height of it during its flight? Label each step. Okay, so here we have this rocket, and I'm going to go time down here, and I'm going to go height here. Okay, so it's going to dramatically take off, and then it's going to start running out of fuel, and then it's going to go down quite rapidly, and then the parachute comes out, and then it looks something like this. Okay? It says to label each step. So far what I have done is I've drawn it. So, rises quickly. Okay, then you're going to get where the fuel kind of is burning out. Or stops rising, then you're going to say drops quickly. This is going to be your parachute moment. And then that's going to reduce it. So you'd have something like that. Okay. Suppose you started to swing yourself on the playground swing. Okay. You move back and forth and swing higher in the air. then you slowly swing to a stop. Sketch your graph. Present how your height from the ground changes over time. Label each section. Okay. If you've ever been on a swing, we're going to keep kind of the same deal here, but you're going to be going up, down, up, down, up, down, up, down, up, down, up, down. Okay, so there would be kind of a sketch of the swings. Now it could be a little bit different than that. I kind of went dramatic there. Okay, so now I need to label everything. Okay, so it's going to look something like this. Obviously, top, bottom, and so on, and you're just going to keep going. And obviously, as you swing, you get higher and higher and higher and higher. And then when you slow back down, you're going to gradually get lower and lower and lower and back to it. There's your homework.